Hello. Today we are going to discuss about some important or the basic concepts of object-oriented programming. Basic concepts of object-oriented programming. So here, this is kind of recalling your previous memory, which you learned in a software construction course. The first thing is abstraction. Abstraction, this is the process of identifying the minimum set of common characteristics of the real world entities. So when we want to program something or design software, if we follow this object-oriented design way, first we have to identify like what are the real world entities that we are going to model in our code or our program, our system. So there, when we identify the real world entities, we have to identify the common set of characteristics. That characteristics can be like the things that the entity can perform and the properties of that entity. For example, if we have a system like let's say a student information system for a university, in that we can identify student as one entity that we are going to model in our system. So when we have that student entity, then we consider, or when we explore more about that entity, and we identify the common set of characteristics. They are the properties of the student, like name, identity card number, registration date, something like that. We identify that all the students have those common set of characteristics, and also the behaviors or the things that the student can do, like register for a course, sit for an exam, ask for a makeup exam, claim the degree, likewise the things that student can perform. So when we identify those things, using that information, we model the student class. That student, we model that entity in our software system. So that's that way we model the class. Class is so we know that class is a template or a blueprint of representing that real world entity. But we know that class is something like it cannot do anything by its own in the system, but to make use of the class, we have to have an object derived from that class. So we have to instantiate the object from the class. So actually in the real world, we see the objects. You are a student, I am a lecturer, so I am one object from which belongs to that lecturer class. You are one object belongs to student class, but in the real world we find the objects or individuals. From that we identify the common set of characteristics and model the class and use that in the software system. Okay, so abstraction is identifying the minimum set of common characteristics of real world entities. And the next concept, basic concept, is encapsulation. So encapsulation is when we identify the real world entities and identify the minimum set of characteristics, we identify the properties and model them as variables in a class, and the, the behaviors we model them as methods in the class. So normally methods are the things that an entity can do, and we have to access or change the values of variables through the methods. When you sit for an exam, you get grade. So through the method of sitting for an exam, the value for the grade will be changed. Otherwise, the value for the grade is not going to be changed. So encapsulation is the process of combining states, or the states are the different values that and variable can take, state and behaviors into a self-contained unit. So let's say this is the process of combining state and behaviors into a self-contained unit. So there should be a connection between the states. States means the different, we can simplify like different values that and variable can take. So states are going to be changed through the behaviors, so through the methods. So we make them in a container called class. So that's the idea of encapsulation. Actually, we know that variables are usually modeled as private variables. So outside from the class, those things cannot be directly accessed, but only through the designated methods which are defined as public methods, those variables can be accessed accordingly. For example, I told you like grade is a variable in a class of a student. Grade can be changed, or the state of the grade can be changed from like none to A or B or something like that through the methods of sitting for the exam. Otherwise, directly we cannot change the state of the grade variable. So normally variables are private, methods are public. Methods can be accessed from the outside, but variables cannot be accessed directly from the outside. Only through the public methods we can access the variables. That is the idea of encapsulation. And there, so we better to talk a little bit about the benefits of encapsulation. Mainly, as we discussed, the benefit is the protection to the data. And also, like I would like to recall the memory about access modifiers. I think you already know about access modifiers: private, public, and protected. So private means only the class members can access that. Public, anywhere, from anywhere that thing can be accessed. And protected means inside the same package member can be accessed. Okay, that's about encapsulation. And the third important point is inheritance. So inheritance is concept of like you already know about generalization and specialization. So when we have something general, that is, the thing belongs to a parent class. But something special, that is, a thing belongs to a subclass of that parent class. Specialization is what is happening in inheritance. So there we have is a relationship. Is a relationship. For example, I can say dog is a or is an animal. So dog is the special thing, specially derived thing from a general thing called animal. General entity is the animal, or animal is the parent class or superclass. From that general entity, special entity is derived, which is dog. Dog is subclass or child class. I think you can understand that. So special entity is dog, general entity is animal. And again we can say like undergraduate is a student. So undergraduate is a special entity, student is a general entity. All the common things we can find from all the students, undergraduate, school, postgraduate, nursery and everything, we can categorize and identify that and make a self-contained unit as a student. From that, we can derive something special called university student or undergraduate student. Let's say undergraduate students. Undergraduate students have all the common characteristics of student, but there may be special characteristics. We can derive them, we can define, or we can code them, or we can say like we define them only in the undergraduate student. But all the common things will be inherited from the student parent class. Okay. And when we have this inheritance, we can talk about two types of inheritance. One is we can say like single inheritance. Single inheritance is single inheritance. So from one parent class, child class will be derived. That is single inheritance. You already know that. Other thing is multiple inheritance. There may be number of parent classes, child class will be inherited. So single inheritance, we can say like from student class we can derive undergraduate student. Multiple inheritance, we can say like two classes, mother and father. From the two classes taking the attributes and we derive a class called child. That is multiple inheritance. But there are some kind of restrictions for multiple inheritance in Java. C++ we can do multiple inheritance. When we have Java, we cannot directly inherit from two classes. Instead, we have to have one class and one interface, and through that we can do the inheritance. So that's different technical topic, but so far we know about the idea of inheritance. So what is the main advantage of inheritance? That is reusability. So whatever the things we define in superclasses or parent classes will be inherited to the child classes. So without coding, without recoding, we can use them. They are just inherit. We do not need to have write the code again and again. So reusability and reusability. There are two types of reusability. One is called design reusability and the other type called code reusability. Code reusability we can do directly from inheriting from superclasses to child classes. But when we talk about the design reusability, that is actually coming with, like, if you have some frameworks are some kind of semi-implemented things. From that we can derive whatever things we want accordingly. So that is kind of reusability. And also design patterns are like some suggestions, or like not suggestions, it's like uh, some ideas to design class diagrams. So that knowledge is kind of design reusability. And when we talk about this inheritance, other important thing is talk about substitution principle. So substitution principle is like, let's say we already talked about reusability. I think you can take the note. And the other thing, substitution principle. Substitution principle is like in a class hierarchy, it should be possible to treat a special object as a object of a base class. I think you got that. So for example, let's say the sentence here, dog is an animal. So there we should have the ability to treat dog as an animal. For example, let's say like now suppose that we have two classes called dog and animal, and dog is extended from animal class. So I am writing a small code like, let's say animal A equals new animal. So what we do is we create an object A which is from animal class, and we create object dog D equals new dog. From dog class we create another object. Now we have two objects. So usually when we according to the substitution principle, we can treat, like we can assign dog object to animal object like this. So this is called substitution principle. A is the base object class, object from the base class. Base class is the animal class. We can assign dog object, that is D, to this base object. This is called substitution principle. But we cannot do like this. D equals A, we cannot do that because D is not the base object. D is coming from the subclass. This is the base object. This is not possible. This is prohibited. We cannot do that. But this thing, A equals D, we can do. This is called substitution principle. And if we do that, let's say like there is a method in dog class, animal class, eat. In the animal class, there is a method called eat. And when we derive the child class dog, we override that eat method. So let's say like here, if we call a dot eat, it will invoke the eat method which is implemented in the animal class. according to the way we implemented it there. And if we override that in the dog class, when we invoke this eat method in dog object, it will invoke according to the way we implemented it in the dog class D. Now we assign the D object into object A. Let's say now we invoke the eat method here. What method will be invoked? So it will invoke the eat method according to the way we implement it in the dog class. Like the overridden method will be implemented there. Let's say there is another special method called bark, but that is only in the dog class, not in the animal class. In the dog class we have a method called bark. So definitely we cannot call a.bark here because there is no method called bark. We cannot do that. Here we can do like d.bark. Perfect, we can do that. But here if we call a.bark, it will not work because in this base object there is no room for bark method. Even though we have this dog object assigned to this animal object, we can only invoke the methods which are defined in the base class. If they are overridden methods will be invoked. But other methods which are only implemented in dog class, we cannot invoke them because there is no room to have those methods in here. So this is according to the substitution principle. Okay. The fourth OOP concept is polymorphism. Polymorphism. So the idea of polymorphism is can have many forms. Poly means many, morph means forms, many forms. I think this is a Latin word. Ability of an object to take on many forms. And also we can say like polymorphism is the characteristic of being able to assign in different meaning to a particular symbol or operator in different contexts. For example, I would say like if we have a super class or parent class called animal, we know that in every animal can, most probably every animal can make a sound, and we derive from that animal class a class called dog. So dog is one specialization of animal, and we can derive another class called lion. We can derive another class called cat. That make a sound method will be inherited to these three different classes. In these three different classes we can override that. Dog, it will bark. Lion, it will make the lion's noise. Cat, it will make the cat's noise. Likewise, the same method, but in the context of three different classes, same symbol or same operator, will operate in different way, in different forms. So that is called having polymorphism in like kind of a real world thing we can see. When we come to object oriented programming, we achieve that using a technique called overloading, sorry, overriding. Overriding means in subclass method body or method implementation, method definition is changing, like making a sound in animal class. When it comes to the subclass dog, the method definition is different to make the barking sound. And when it comes to the cats class, it is different to make the noise of cat. To the lions class, it is different implementation to make the noise of lion. That is called overriding. We achieve polymorphism through the overriding technique. So there, all the methods, the superclass methods and subclass methods, the method we are going to override, they have the same method name, same return type, and same parameter list, but only the method implementation is going to be different. Other things are the same. And at the same time, I would like to talk a little bit about overloading. Overloading is in a class. So in overriding, we have superclass and subclass relationship, but when we come to overloading, there's no superclass and subclass. It is happening in the same class. Same method, but different, like same method name, but different signature. Different signature means different parameter list. Same method name, same return type, but different parameter lists are there in three different methods. So we can have multiple, let's say like constructors. Likewise, parameter list is going to be the difference. But when we have overriding in the superclass and subclasses, method name, return type, and parameter list, everything is going to be the same, but only the method definition is going to be changed, or the implementation of the method. And another thing, we discussed about substitution principle here. So when we substitute that, like substitute A, like we assign D object to A, that is called, like according to substitution principle, this is called dynamic binding. In the runtime, we can do this. In the runtime, we can do this. So later time, we can assign another object to this superclass object, another object from a subclass. Let's say if we have cat class extended from animal class, we can assign cat object to here at the runtime. Okay, so this is what I wanted to talk for the moment, and later I will again upload another lecture which is about association among classes, like aggregation, composition, like those things, and some coding examples about that. Thank you.